the next presentation is going to be given by Burton Suedel. Burton is a close colleague of mine. I say that with the hopes that you will not hold that against him in any way. We've worked together for many years on a variety of problems dealing with sediments, and in the last several years on something much more positive, and that's in the context of our Engineering with Nature program in the United States, where we are also seeking these kinds of triple win opportunities and values. And that is what Burton is going to summarize today, one project on the Atchafalaya River in Louisiana. So welcome to the podium, Burton.
Thanks, Todd. Peter and Yap, I would be glad to join you on this journey. And my presentation today provides a case study example of how we implemented the philosophy of working with nature through our Engineering with Nature program within the Army Corps of Engineers. This is related to the strategic placement of dredge material along the Gulf Coast of the United States. Peter and Yap did a really good job of explaining the relationships between the with natures just a few minutes ago, so I'm not going to go into this slide in any great detail, but certainly in the United States within the Army Corps of Engineers, we do use the Engineering with Nature program to essentially implement the working with nature philosophy more broadly on a wide variety of dredging and navigation projects. To orient ourselves and to get into a little bit of a deeper dive on this project, here we are on the Gulf Coast of the United States. This is actually in the state of Louisiana. And this coast in this particular project is very close to the Gulf of Mexico along the coast of Louisiana. The area of interest for the project is right here. This is along the lower reaches of the Atchafalaya River, and the nearest town and the city and port is the port of Morgan City to the north. And the project site was right there in the middle of that yellow hatched area. In a situation that we find ourselves fairly regularly, unfortunately, certainly in the United States within the Army Corps of Engineers, is this idea that we begin to run out of places to dispose of, or more appropriately, I think, to place our dredge material. You see over here in this particular image, our district had placed this material in a wide variety of locations over a period of over a decade to create some wetland habitat along the bank lines of the lower Atchafalaya River in this particular area. But they soon ran out of placement area room, so they had a decision to make. And so over on the right-hand side shows you some of the alternatives they considered with this dredge material going forward. And fortunately for them, what they had decided to do is this mid-river mounding of the dredge material. The engineers within our New Orleans district had a really good sense of the hydrodynamic processes that were occurring in this part of the river, and they were fairly confident that if they relocated this material strategically, they would be able to actually create riverine island habitat. And so here we are back in the late 1990s. This is also Horseshoe Bend. What they had seen here was the relatively persistent sandbar in that particular location, and they wanted to try to take advantage of the hydrodynamic processes of the river in this particular location, and they wanted to mound that material in that general area as they maintain the federal navigation channel that is in that general area. And so that was the impetus for the project. Here we are about 12 years later in 2010, and you can see after multiple placements, strategic placements of the dredge material, here in 2010 you can see two of those dredge mounds that are still present from this photograph. But you can see that the island has grown substantially. That original sandbar was in this general location, but you can see the island has grown substantially as a result of the strategic placement in this general area. The table over here on the right gives you a sense of the growth of the island over time. It's not linear as you might expect in such a dynamic environment, but as to this date, we've got about 35 hectares of high-quality riverine habitat. In spite of the good practices that our district was performing in this, for this particular project, they had very little information about the quality of the habitat that it had formed. They really didn't have any information on that, and so they reached out to us to develop a multi-factor analysis to help understand really and quantify the benefits that are associated with that island habitat. And so in looking at the environmental benefits, the things that we wanted to investigate is to identify and classify the distinct habitats types that were present on the island, catalog the plants and the animals that were present, and evaluate the soil horizons. We also wanted to compare this island to two other island habitats, one natural, one also more typically designed habitat feature related to more a confined disposal facility that the Army Corps of Engineers had developed in years earlier. So I don't have time to present those comparisons to you, but some of the creatures that were on the island are seen here. They actually are connected because if we're not careful, we're going to step on this right here, which we're actually waiting under these nests for the nestlings to fall out and collect an easy meal. So we had to make sure we did not get our legs bit off. Here are some of the results of the habitat classifications. The picture on the right-hand side gives you a good indication of the three types of the four habitat types that we identified on the island. The young forested areas you see in the background. In the foreground, we have the aquatic bed features, and then the emergent wetlands transition is indicated in this particular area. So we have a wide variety of productive habitat types that have formed on the island. Also importantly, too, as I mentioned, we had a pretty strong indication and understanding of the hydrodynamics in that system, but nevertheless, after the island's development, we actually didn't have any hydrodynamic models to help explain and really to confirm that it was in fact that strategically placed material that was actually relocated to the island. And so our hydrodynamic modeling effort did indicate that we had strong forces present to relocate that material and create that island. Some of the environmental benefits, 4 distinct habitat types. We got over 35 hectares of habitat, 80 plus plant species, 20 plus animal species were observed on the island. And importantly, a large wading bird rookery had formed on the island. Here's another picture of that's a black ibis. That nestling had not taken flight, but it's almost about 1 meter tall. So the substantial rookery there was an important environmental benefit associated with the island, probably because it was not connected by land, and those birds had relative safety from a wide variety of animals that might otherwise take advantage of the rookery. Geomorphological and nutrient cycling analyses were also performed. It was important for us to understand the quantity and particularly the quality of the soils that had been deposited on the island. And so those soils were dark and organic rich surface soils. That soil quality was important because it has to support a wide variety of plant life as evidenced in photos, but also importantly the microscopic and bacterial and soil fauna also related to those soils. Resultant chemical reduction was observed, and so the island is actively sequestering carbon and also cycling nutrients, particularly nitrogen. Particularly relevant to why we're here today is the navigation and climate benefits that were realized as a result of the project. To orient you, this was the original federal navigation channel here. An interesting thing happened when that island formed over that 12 years. A naturally occurring channel actually developed over here to the east of the island, sufficiently so that over time, back in 2015, the United States Coast Guard that has oversight on this actually permanently realigned the channel as indicated here by the red dots. Not so much significant in and of itself, except for the fact that that reduced the length of the Federal navigation by 0.7 nautical miles. And so by doing so, the sharp bends along Horseshoe Bend were eliminated. So from a pilot perspective, you're really happy about that because that improved navigation safety. Importantly, from the Army Corps of Engineers perspective in dredging, that substantially reduced long-term dredging requirements. Instead of having to dredge the old channel on an annual basis, we now just have to dredge that channel about once every 4 years. And so we have a substantial reduction in our dredging costs, but also importantly, we have a substantial reduction. We have the substantial increase in carbon savings and reduced air pollution, not only as a result of the reduced dredging operation, but the fact that all those vessels that are traversing the channel also have reduced energy requirements. And so one of the important aspects and objectives of the project was also to quantify, to the extent that we could, some of the environmental and other benefits associated with the project. And so in this table gives a general summary of what we had observed. The carbon sequestration here, this was just based on the emergent wetlands present on the island, roughly a little bit more than 6 hectares. And based on our estimates, the average carbon per year that was sequestered is over 5,000 kilograms. So we're sequestering a substantial amount of carbon in those soils. Water purification, particularly relevant in this part of the United States along the Gulf Coast. Some of you may realize we do have that large hypoxic zone that tends to develop in the Gulf of Mexico waters in the spring and summertime in particular. And so water purification is not insignificant from a broader perspective. We do realize that this is a relatively small island, so our nitrogen reduction per year is going to be relatively modest, but nevertheless, those are real benefits. Climate regulation, obviously relevant. We work with the Port of Morgan City here, what helped us develop the data. We had roughly 1,400 trips per year for a wide variety of vessels that are using that federal navigation channel. And with the assumptions and calculations from them, we are seeing 186 metric tons of carbon dioxide equivalent per year that are being saved. So that's relatively substantial. We got educational support related to the project study. The navigation related to dredging here, as I mentioned before, instead of dredging annually, we're now dredging only once every 4 years, and so we are actually saving about over $4 million a year just in dredging costs. So it's fairly substantial. So what have we learned as a result of the project? 4 distinct wetland types were observed. Compared to the natural wetland in the area, we have substantially more plant species, 80 versus roughly 50 in the naturally occurring island. And so I think this habitat development is doing a great job. I think one of the most important things here is thinking about that engineering up front. It's not so much that we did less engineering, but we did engineering a little bit differently here. To allow that island actually to self-form, I think really increased the habitat value associated with the project, and I think that contributed to the wide variety of plant and animal species that were observed utilizing of the island. And of course, importantly here is the multiple benefits were realized, and we calculated several of those as a result of the project. And so some of the takeaway points then. The effective waterways management is something that we're continuing to practice within the Army Corps of Engineers, and to the extent that we can identify and communicate those within and outside the Corps is certainly something that we like to do on a regular basis. One of the things that tends to happen, though, within us organizationally is the idea sometimes when we place that last stone, when that last particle of sand is dredged, the project is over. And so sometimes when that happens, we don't really communicate or write down some of the good things that we've done. So it's very important for us to communicate some of the good practices that we're doing. Otherwise, I'm not standing in front of you today and telling you about these types of projects. And I think this is another good example. Peter Nyap gave us a good example just a few minutes ago about utilizing nature's energy. I think this is a really good example of how we can do that very thing in a coastal area in a riverine environment. So this is a certified working with Nature Project, and we actually won the Western Dredging Association's top award 2015 for environmental excellence. And perhaps importantly for some of you, those documents there on the far right gives you an indication, yes, we have a lot of good documentation on this project. Now, I know I've only had about 15 minutes in front of you today, but if you would like additional information on the project, do not hesitate to let me know. I'll be glad to send that to you. Thank you.